triple, right? And then so eventually we get down to here. What are we going to have to multiply the 7 to get 42? 6. So we can just multiply these numbers by 6, and we'll get 6 times the 7, which is 42. We'll get 6 times the 3, and we'll get 6 times the 4. Again, you can continue making this table, right? This would be 12. That would be 16. This would be 15. That would be 20. And I think, yeah, the next one, so there's nothing here. The next one would be right there. Okay. But again, if we could figure out how do we multiply this so that that becomes 42, that's a lot quicker instead of making this whole table. Doubling the numbers, tripling the numbers, multiplying by 4, multiplying by 5, and then now multiplying by 6. That's a lot easier. This works, though. Okay? And so someone said that in the chat. So here's an equation we can solve. What do we multiply these numbers by so that that becomes 42? And then once we get k, which we already know is 6, we just multiply these numbers by 6. Called a scalar. It scales the original numbers. We need to rescale these numbers so that the sum is 42. Now it's 7. And we want the 7 to become 42. So if we multiply all this by 6, we'll get down to here. Now that's the same thing we were doing with the paint problem, if you remember, except we had 3 colors. We had a triple ratio, but it's the same thing. We would have had an extra term here with the number times k. And then this scalar gave us the number to multiply to the original ratio numbers so that the sum is correct. All right? We could also set up a proportion. So if this is based out of a total of 7, what would they be based out of a total of 14? So we could solve 3 over 7 equals what over 42? Or 4 over 7 equals, and I'll just use a different variable, what over 42. So you could do that. You could create the parts to total ratios. The total would be 7, 3 out of 7, and 4 out of 7.